Hello, you are welcome to Best Brain Academy. My name is Dr. Kingsley. In this class, I'm going to be taking you on phenols. Okay? Now, we'll start by knowing what phenols are. Now, look at the structure on the board. Okay? If you look at this structure on the board, it is called phenol. Now, what are phenols? Phenols are aromatic organic compounds, okay, having a hydroxyl group attached directly to a benzene ring or any aromatic ring. Phenols are aromatic organic compounds that have the hydroxyl group directly attached or directly bonded to aromatic ring or benzene ring. Now, phenols differ from alkanols. Now, if we look at the structure here, you see that this is an alkanol. This is an alkanol. Why this is a phenol? What's the difference? Now, in alkanols, the hydroxyl group is bonded to a carbon that is sp3 hybridized. While for phenols, the OH group is bonded to a carbon that is sp2 hybridized because it's bearing a double bond. So that is the difference between alkanols and phenols. Phenols, the OH is bonded directly to aromatic ring, benzene ring. Okay, and the carbon is sp2 hybridized. While for alkanols, the OH, which is the hydroxyl group, is bonded to carbon that is sp3 hybridized. Okay, now what of this? What do we say of this compound? CH2OH. Okay, is it a phenol or an alkanol? Now let us analyze. This is the OH. The OH is bonded to this carbon atom. It is not directly to the benzene ring. Now, this is how many hydrogen? This is 2 hydrogens. So we can represent this hydrogen as H and the H. Okay, that is a 2 hydrogen. This is a single bond, single bond, single bond, single bond. This carbon atom is sp3 hybridized. So this is an alkanol and not what? Phenol. Remember, for phenol, this OH, the hydroxyl group, will be bonded directly to the what? To the benzene ring or the aromatic ring. I bet now you now know what phenols are. What are the physical properties of this phenol? One, phenol is slightly soluble in water. Why? Because it has what? A hydrogen bond. Now, if you look at phenol, this is OH. This is what? Hydrogen bond. Okay? Since it's having a hydrogen bond, it should be soluble in water, although slightly soluble in water. Okay? Less soluble than alkanoic acid. Now, number 2, phenol is a colorless solid. Colorless solid. Although it can be oxidized when you expose it to air and the color changes to brown. Okay, that is one, number 2. Then number 3, phenol, okay, have a characteristic smell. So there is a smell, the phenol smell, characteristic smell for phenols. Now let us look at different types or forms of phenols. We have number 1, monohydroxy phenols. That is number 1. Monohydroxy phenols will include the phenol itself, okay, OH. That is phenol. That is monohydroxy phenol. Then monohydroxyphenol, of course, from the word mono, it means one. So that they should be having only one hydroxyl group. So when I have OH, which is phenol, and I bond CH3 methyl group to it, okay, this is called cresol. Cresol. Now, cresol is a monohydroxy phenol because it's having one OH. Cresol is actually what? It's actually 2-methyl, phenol. 2-methyl phenol. Of course, you know, when we have a group here, OH, okay, that this place is called ortho position. That is represented by O. This place is called meta position, represented by M. While this place is called para position, okay, represented by P. Now, when you look, you see that what? That the methyl group is at number, this is 1, 2 carbon, 3, 4, 5, and 6. Since it is at number 2 carbon, look at number 2 position. It's taken as what? Ortho position. Since it's ortho position, that means that cresol, which is 2-methyl phenol, can also be called O-methyl phenol. So cresol is also called O-methyl phenol because number 2 position here is the ortho position. Okay, so cresol is of course monohydroxyl phenol. Then we can also have the OH here and the CH3 here. Okay, this is the P-methyl phenol. P-methyl phenol is 1, 2, 3, 4, which is what? 4-methyl phenol. Either you call it P-methyl phenol, or you call it 4-methyl phenol. Now let us go to dihydroxy, phenol. Dihydroxy phenol, they are having two, OH group. They have two OH group. That is another form of phenol. Okay, let us look at this. This is OH and this is OH. If I should number, this should be carbon number 1, 2, 3, 4, 5, and what? 6. So that is what? 1, 2 dihydroxy. 1, 2 dihydroxy benzene. Okay, benzene. 1, 2 dihydroxy benzene is a catechol. It can be called what? Catechol. So catechol or 1, 2 dihydroxy benzene, is a dihydroxy phenol. Then we can still have one tree. Okay, where we have the structure. Okay, this is OH and this is what? OH. Okay, this is a 1, 3 dihydroxy. 1, 3 dihydroxy benzene. 1, 3 dihydroxy benzene is known as a resonol. It's also known as a reson or resorcinol. It's known as resorcinol. So resorcinol is a dihydroxy benzene. So we can also have OH. This is what? 1, 4 dihydroxy. Benzene. 1, 3 dihydroxy benzene is known as a hydroquinone. You can call it a hydroquinone, or hydroquinone. That is another what? Dihydroxy phenol. Then we also have trihydroxyphenol, trihydroxy. Okay, number 3, trihydroxy, okay, phenol, trihydroxyphenol. So let us give a structure. You have a OH, and OH. Okay, that is 1, 2, 3, 4, 5, and 6. So that is 1, 2, 3. Trihydroxy benzene. Okay, that is a pyrogalol. We call it a pyrogalol. Okay, pyrogalol. That is a trihydroxy benzene. Okay, then number 4, we have a polyhydroxy. Okay, phenols. Polyhydroxyphenol. Example of polyhydroxyphenol, okay, is a tannins. Okay, that is a tannic acid. Okay, they have so many OH. Okay, that is substituted. Now I know you have enjoyed this class. Before I go, please help me subscribe to this video, like and share. Subscribe to the channel, I mean to say, like and share, so that I can get to other persons. Thank you.